Okay, so we're starting chapter 2 today. We're doing conditional statements. So let's start with what is a conditional statement? Well, let's talk about when is a conditional statement true or false. So we're going to write conditional statements. We're going to use definitions and write biconditional statements. So let's talk about a conditional statement. A logical statement that has two parts, a hypothesis and a conclusion. They're going to be written in what's called the if-then form. So in other words, if the hypothesis, then the conclusion. The words will be if P, then Q, and the symbols are written as P, then Q. And the little arrow stands for then. So when you see this, it's like saying if P, then Q. All right. You're going to have to do a lot of writing today. So if I go too fast, that's what the pause button's for. So make sure you pause, rewind, make sure you get everything you need. So the first thing we're going to do is underline the hypothesis and circle the conclusion in each of the following conditional statements. So in number 1, the conditional statement says if an angle measures 30 degrees, then it is an acute angle. So if an angle measures 30 degrees, and angle measures 30 is your hypothesis, it is an acute angle is your conclusion. The words if and then are not part, okay? So please do not circle or underline if and then. Those are just the keys to let you know if this is the hypothesis, then this is the conclusion. And the second one, if two angles are adjacent, so there's your hypothesis, then they have a common side. And number 3, if two lines intersect, then they form a right angle. So for example, if you do your homework, then you will not get a 0. Cause and effect. All right, so we're going to underline the conclusion or the hypothesis, circle the conclusion, and we're going to rewrite them because these sentences are not given to us in a normal, typical form. So for example, all even numbers are divisible by 2. Well, that doesn't say if something, then something else. So the way we would rewrite it, we could say if a number is even, then the number is divisible by 2. So these two things are saying the same thing, even though they're written a little bit different. Number 5, you are in Texas if you are in Houston. Of course, we could rewrite that one as, oops, if you are in Houston, then you are in Texas. So, like I said, if I'm going too fast, you can pause and rewind so that you can get it all written down. All right, negation. Negation is exactly what you think it means. It means the negative, the opposite. So the opposite of original statement, we're going to use this little squiggly symbol right here. I don't know if you can really see it. It's squiggly. On your keyboard, if you're looking at a keyboard, it's next to the number 1. It's the little squiggly. The way you say it is not. The squiggly means not. So for example, if I wanted to say not P, then I would write squiggly P, and I will refer to it as squiggly. So if I wanted to write the negation of an angle is a right angle. So what would the negation be? How would I say that opposite? I would say an angle is not a right angle. Kind of like if I say the sky is blue, the negation would be the sky is not blue. All right, so here's where you're going to write a lot. Okay, there are 4 types of statements, okay? We have conditional statements, which are what we've been starting with, which is if P, then Q. Then we have the converse, which is the conditional backwards. So if Q, then P. Then we have the inverse, which is the negation of the conditional. So not P, then not Q. And then the contrapositive, which is the opposite of the converse. So not Q, then not P. So we're going to take the hypothesis, you are a guitar player, and the conclusion, you are a musician. and we're going to write conditional statements. So if I were to take if P, then Q, then it would look like if you are a guitar player, then you are a musician. So would this be true or false? So think about it. If you are a musician, if you are a guitar player, then you are a musician. Well, that would be true. I'm going to go ahead and circle true. All right, now let's look at the next one. If you are a musician, then you are a guitar player. This one would be false because you could play something else. Now the inverse is saying the conditional. So see how the symbols are similar, but these are negated. So this would be, if you are not a guitar player, then you are not a musician. And would this one be true or false? So if you're not a guitar player, so I'm not playing the guitar, so I'm not a musician. This would also be false because I could be playing the drums. And then the last one is contrapositive. If you're not a musician, so I'm not a musician, then I'm not a guitar player. That is true. That is very true. If I'm not a musician, I'm not playing anything. So do we have any questions? Think about them, write them down. All right. So if you'll notice over here, we have true, false, false, true. This is where we get into equivalent statements, okay? So two statements that are both true or both false. So notice above, the conditional and the contrapositive were both true in this case. Not always, but in this case, in our example. And then the converse and the inverse were both false in our case. It could be that they're both false, then they're both true, okay? The conditional statement and the contrapositive are both true or both false. And then the converse and inverse will be both true or both false. So let's decide if these statements are true or false based on this picture. So AC is perpendicular to BD. Is AC, which is this line here, perpendicular to BD? Yes, it is. And we're going to explain it using a definition. So our definition is that it has a right angle symbol and the lines intersect to form a right angle. That's how you get a perpendicular line. Angle AEB, so AEB is this angle here, and CEB are a linear pair. Well, from our last set of notes, yes, that's true, because you've got these opposite rays. You've got this ray going this way, and then you've got the ray going this way, and opposite rays form linear pairs. EA and EB. Well, EA goes this way, and EB goes up this way. So they are not opposite rays. They don't even lie on the same line. So to be opposite, they have to be collinear. So maybe make yourself a note here to remember that they have to be collinear. So to be opposite rays, the line, I can't type today. The points have to be collinear. All right. Now, biconditional. A biconditional statement basically is when the conditional and the converse are both true. So in our example about the musician and the guitar, the conditional was true, but the converse was false. If they had both been true, then this would have been a biconditional statement, and it would be written as P if and only if Q, which means no matter which way I say this, it's true. So in our definition here, it says if two lines intersect to form a right angle, then they are perpendicular lines. So is that true? So if two lines intersect to form a right angle, so if two lines intersect to form a right angle, they are perpendicular lines. This is a true statement. The hypothesis, two lines intersect to form a right angle. The conclusion, they are perpendicular lines. Now write the converse. So now let's write it backwards. So this time we're going to write it backwards. It has to be Q, then P. So then we're going to have to say if two lines are perpendicular, then they intersect to form a right angle. So if two lines are perpendicular, then they intersect to form a right angle. Is this true? So if two lines are perpendicular, then they intersect to form a right angle. See how that one is also true. So since I have two true statements, this is a biconditional statement. So I would rewrite it as two lines intersect to form a right angle if and only if they are perpendicular lines. So we'll get a lot more practice tomorrow in class, and I will see y'all then. Have a good one.